Alright, so this is the video for the last of the tests that you're going to be retaking. It's the test for Unit 4 and Unit 5. This was the first question. It says, which graph shows that a person walked toward, and the key word there is toward, the motion detector, and then stood still. So this first part, towards, that means the distance is decreasing. So the person is going towards the motion detector, so they're going from far away to close together, so that means this part of the line is going to be a decreasing line. And then stood still means the second part of the line needs to be a horizontal line. So I want a line that's the distance is decreasing and then is horizontal. So this one is horizontal and then increasing, that's nowhere close. This is away and then stops. This is stopped and then towards, so that's close, but it's in the wrong order. And then this one is towards and then stopped, and so the correct answer is D. Okay, number 2. Number 2 is the reverse of number 1. So we've got the graph and I want to make the story. So I've got here a line that the distance is decreasing and then turning around and increasing again. So I've got one that's the distance decreases, he's moving towards the detector, and then he moves back away from the detector. So towards here, then away. So this is away and then towards, that's wrong. Towards and away, that's a possibility, so I'm going to keep that one in my mind, this B here. So that's towards and away, that's good. And then the other one that's towards and away is here. So I'm choosing between these two options here and here. So let's see, now I need to look at which one of these is faster. This is steep, so if I put a ball on the top here, it would roll down because it's steeper, and then this is less steep. So if I were going to say which one of these two segments, this segment or this segment is faster, this part is faster than this part. So first he moves towards quickly and then away more slowly. So let's see, towards slowly, towards yes, but not slowly. I wanted towards quickly and then away slowly. So it's important, these two are both possibilities. You need to look at the steepness of the graph. Okay, number 3. Describe a graph that represents Winona starting directly in front of the motion detector, then moving away for a slow, steady rate. So let's look at what that graph would look like. So Winona starts in front of the motion detector, she moves away. She starts directly in front, which means she starts at 0, and then she moves away at a slow, steady rate. Okay, so she starts directly in front of the motion detector, so the distance is 0 because she starts directly in front of it. And then a slow, steady rate would be a line that is straight because it's steady, and it's also not steep. And the reason why it's not steep is because it was a slow, steady rate. Okay, so let's see which one we got. Curve, absolutely not. It's not a curve. Horizontal line, no, that would mean she was stopped altogether. Steep line, no, she wasn't a steep line. It wasn't a fast, steady rate. It was a slow, steady rate. And this one, the graph is a relatively flat line that begins low on the y-axis and rises as it moves. Okay, well, let's look. A relatively flat line that begins on the y-axis and moves up relatively slowly. Well, that sounds good. So the answer here is D. I'm probably going to break this video into 2 parts. Next question, Robbie stands in front of the motion detector and freezes. All right, so we know what that means is a horizontal line, a flat line. He has forgotten what he's supposed to do, so he stands without moving. Okay, still like that. How would this graph of standing look like? All right, the only thing that we need to know is the word horizontal. So this graph stays at the same distance, so it doesn't changes, and we just need to remember the word horizontal. If somebody stands still, that means it's a horizontal line. All right, which is the rate of change 0? Well, that's the same as the question we had before. If the rate of change is 0, what kind of line is it? It's a horizontal line. So that's one where the rate was 0, and that was A. Next question, which one of these is negative? The one that's negative is the one that's going down and not up. So C is going up, D is going up, and A we talked about last time was 0, so the only one going down is B. And the next one is probably the steepest. Okay, so which one of these is the fastest rate? That means which one is the steepest. If you put a ball on this graph and let it roll, where would the ball speed up the fastest, the steepest part? And that's here, C. So that represents where the distance is increasing the fastest. Which table of data could you collect by walking away from a motion detector? That means the distance should be increasing or decreasing away. Well, away means the distance is increasing. So I want a distance to be increasing. So let's see. 10, 10, 10, 8, 8. No, that's decreasing. So I want the distance to be increasing because I'm walking away. 3, 3, 5, 7, 9. That's closer. That's increasing. 3, 5, 7, 9, 11. This one looks good. Let me double check here. 9. So no, this person's working towards. This person is about to hit the motion detector because the distance is about to be 0. So let's see the one that has the constant pattern. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So these numbers are increasing, moving away, and it's also a constant rate, which means that they're increasing by the same amount each time. So there were two parts to this. Moving away, which two of these were moving away? Not this one, that's moving towards, the numbers are decreasing. Not this one's moving towards. So these were the two possibilities for away. Okay, and then how do I pick between them? Which of these two has a constant rate? Why was this not a constant rate? Well, because it went 3, 3, 5, 7. It has to increase by the same amount each time. This person was standing still at first because their distance wasn't changing. So this is away and at a constant rate. So that's the answer for that one. 2 more to go. T-shirts, which one of these is true? Is it a constant rate? 10, 5, 20, 25, 30, 35. Yes, it's a constant rate, so that's not true. Proportional relationship and the constant. How much does this increase each time? $5, $5, $5, $5, $5. So when I buy an extra T-shirt, the cost of the shirts goes up by $5, and so that's this answer here. The data is a proportional relationship, and the constant proportionality is $5. The reason why this is not correct is because they do represent a proportional relationship. In other words, this is a straight line. And number 10, what's the rate of change? I need to figure out, to find the rate from a table, first I subtract these two numbers and then I divide those two numbers. Let me do this calculation by hand. Alright, this is the last one that I wanted to do, and the way to calculate a rate using a table is first to subtract, that is to subtract the numbers in the table, and then divide. And the reason why is because I want miles per gallon, or in other words, I want to figure out how many miles I can go on each 1 gallon of gasoline. And let's see, each time the gasoline changes by 1, that's from 2 to 3 is 1 gallon, 1 changes by 1, changes by 1. Okay, so this side is 1 gallon. And then this other side here, how much does this change? Well, from 120 to 90, it loses 30. Let's see if that keeps working. 90 to 6, 9 minus 6 is 30. 6 minus 3 is 30. Okay, so let's go ahead and divide now the number, how much the miles are changing. Miles divided by gallons. Miles per gallon. Miles divided by gallons. So I'm first subtract to find how many miles is changing, and also how much the gallons are changing, and then divide. Divide how much the miles are changing, miles per, or divided by gallons, how much the gallons are changing. So my miles was 30. Per means divide, and then 1 gallon. I go 30 miles per 1 gallon, and that means that this car gets 30 miles per gallon, and I'm going to abbreviate that MPG. Okay, so the answer here is 30 miles per gallon.